So welcome to today's lesson. In today's lesson, we are going to learn how to solve systems of linear equation using the Cholesky method. I'm Boydo Canrino. So with the Cholesky method, when you're solving a system, we first write our coefficient matrix. So this is going to be our coefficient matrix here. Before we can use the Cholesky method, we have to check whether our coefficient matrix is symmetric or positive definite. So to check that it is symmetric, that means that A should be equal to A transpose. So you realize that when you find the transpose of our matrix A here, we get this, which is equal to A. So that means that it is symmetric. So the next thing for us to do is to check whether it is positive definite or not. So for it to be positive definite, then all the leading principal minors should be greater than 0. So when you check for the third principal minor, you realize that that's what we have here. So the determinant of this 46 is equal to 46, which is greater than 0. When it comes to the second principal minor here, leading principal minors, we have the determinant of this, which is also greater than 0. And when you take the determinant of the full matrix, it is also equal to 1, which is greater than 0. So it means that our matrix is positive definite. So hence we can use the Cholesky method. So what the Cholesky method does is that our matrix A is factorized into a product of a lower triangular matrix and its transpose. So we can call it H transpose or L transpose, where our H in this case, but when we use this, that means our L is the lower triangular matrix and the transpose of it is the upper triangular matrix. So we are using H. So we let H be this lower triangular matrix here. So the upper triangular matrix is going to be the transpose of it. Note that we only use this method when our matrix is symmetric and positive definite. So our A is equal to H transpose, where this is our lower triangular matrix and this is our upper triangular matrix. So when you get here, you can just do matrix multiplication and make comparison. But we have a quicker way of doing it, and that is to use the Cholesky method. So you can just decide to multiply these two matrices, and you, by equality of matrices, you compare. You get the same answer as using the Cholesky algorithm. So the Cholesky algorithm makes our work faster. So I have the Cholesky algorithm here. So this is what the Cholesky algorithm says. So it says that for our h11, we should always set our h11 to be root of e11. Then for k equals 2 up to n, we should let hgi be equal to hg1 all over h11. Then it continues that way. So I think this should be k. So this is the algorithm, right? So let's come back to our question. So at k equals 1, using the algorithm, you have h11 will be equal to root of e11. So later on, make sure you go through the algorithm. It is very simple, it's just an iterative method. So when k is equal to 1, the first step, we said we set h11 to be equal to root of a11. So that means h11 will be equal to root of 1 because this is our a11 and it is 1, which gives us 1. So then we've been able to find for h11, we are left with 5 unknowns. Then our h21, remember we said our k1 is equal to a k1 all over h11. So that means that k is 2. So our h21 will be equal to a21 over h11 from the algorithm. Then as I go through the algorithm, it will be so simple. So our h21 here will be equal to a21 over h11. So this is our a21. So 1 and h11 we just found it to be 1. So that means that our h21 is 2. Then from the algorithm, h22 is equal to root of a22 minus h21 all squared. So from here, our h22 here is 5. I hope you can see that. Yeah. And we found our h21 to be 2. It's going to be 5 minus 2 squared, which will be root of 1, which will be equal to 1. Then at k equals 3, our h31 is equal to a31 over h11. And our a31 here is 6. It is symmetric, so 6 here or 6 here. Yeah, same thing. So we're going to get the 6 over 1, which will give us 6. Then our h33 is equals 1 over h22, a32 minus h21, a31. So you realize that our h22 has been found to be 1. So we found it to be 1. Then our A32 in the question is 15. You can check the matrix. Our A21 has been found to be 2 and A31 6. So when you put everything in, you are going to get H32 to be 3. Then with our H33 is given us, so you know that we are getting all these from the Cholesky algorithm. Or as I said, you can also do matrix multiplication and by equality of matrices compare. So we have our H33 will be equal to A33 minus H31 squared minus H32 squared. Our A33 is 46. Our A31 we've computed it to be 6 and our H32 is 3, which we just computed here. When you put everything here, you're going to get A33 to be 1. Right. So now we found for all the 6 unknowns. So our lower triangular matrix is given as this particular matrix here. So when you replace it, H11 was 1, this was 2, this was 1, this was 6, this was 3, and this was 1. So that means you are done with the lower triangular matrix. And we said our upper triangular matrix is just the transpose of the lower triangular matrix. So that gives us this U. When you finish, then you ask yourself this question: is my L times U equals A? That's correct. Then that means that the decomposition you did is right. But if it is not up to, equal to your A, that means that you might have made a mistake somewhere, so you have to go through. So when you multiply our L here by our U here, fortunately for us, we will get A. So that means that we did the right thing. So the next thing is to find the intermediate solution. So with that one, we solve Ly is equal to B for some y, where L is our lower triangular matrix. So this is our L and this is our y equals the B from the question. So the constant from the question. So when you do this, you know this matrix has already been reduced for you. So doing it is so simple. So when you do this, you get your y1 to be 2, your y2 to be negative 1, and y3 to be 3. And this is the intermediate solution. So when we are done, then we solve ux equals y for the system solution. So this is our upper triangular matrix. This is our x's that we are finding for, and this is our y, which we just computed here. So when you solve this to this one too, you know your matrix here has already been reduced for you, so there is no need for you to use the Gaussian elimination because it's already in the upper triangular matrix form. So when you do it, you get your x1 to be 4, x2 to be negative 10, and x3 to be 3. So this happens to be the solution to our system. So once again, we did that using the Cholesky algorithm. And this is how the Cholesky algorithm looks like as I've explained. So that's the Cholesky algorithm. As I told you, if you can't really understand the Cholesky algorithm, then you can just multiply the two matrices and by equality of matrices compare. Alright. So thank you very much.